One of the things that you will notice in this beginning slide is I begin with a quote from Winston Churchill. If we open the quarrel between the past and the present, we shall find that we have lost the future. And why I include it and why do I think it is very important, I will make explanations towards the end of my presentations. Now, just to start off, to introduce myself, my name is Lim Tze Tshen, and what am I doing over here, and what sort of scientific research that I'm doing? First of all, I'm a paleontologist. I study paleontology, which is the scientific systematic study of fossils, animals and plants remains preserved in the hard rock layers of the earth. And the group that I focus on is animals. So on your top left, you can see that there's a plant fossils. I'm not an expert on plant fossils, so I'm not going to touch on plant fossils today. Like I said, I'm specialized in vertebrate animals. So I study animals with the backbones. So over here you can see there's fossils, trilobites, and this is invertebrate animals, the precursors of insects. Because I'm not specialized in invertebrate animals, so I'm not going to talk about it also. And even though this is one of the famous dinosaur Protoceratops, it's vertebrate animals, but I'm not a dinosaur expert, so I'm not going to talk about dinosaurs today. So if you are interested in dinosaurs, you may feel a little bit disappointed. What I studied are mammals, including humans. And I touched on a little bit on humans as well, but most of my research I focus on non-human mammals, animals. And in recent years, I also ventured into the field of archaeology, which is the scientific systematic studies of cultural artifacts left behind by prehistoric and historical human populations. For example, stone tools, prehistoric porcelains, ancient rock art, and also some of the burial jars from Borneo, and also the hieroglyphics from ancient Egypt. But I do not study these conventional archaeological artifacts. I specialize in a specific field of archaeology called zoological archaeology, or zooarchaeology in short, which is the studies of non-human animal bones from prehistoric archaeological sites. And these bones are not any regular bones. They are simply the leftovers of prehistoric huntings. So for most of the time when I'm doing archaeological research, I basically rummage through the prehistoric and ancient kitchen refuse. That is a valid reason why we want to study the animal bones from archaeological sites, because by studying that in a systematic ways, we may be able to know more about the behaviors of ancient prehistoric humans that usually not fossilized in archaeological sites. So, like I said, in fossils, paleontological research, and also zooarchaeological research, I focus on animals with backbones, vertebrates, like elephants and rhinos. And I'm also interested in the modern day mammal faunas of Southeast Asia, especially in Malaysia. In Malaysia, we have a highly diverse mammal fauna because Malaysia is together with the other countries in the regions are located somewhere towards the equators. And this is a geographic hotbed for evolutions, for the origins of so many species. And that's part of the reasons why Malaysia has such a high diversity of mammals in the world. And one of my key research in recent years is I want to find connections, meaningful connections between the old bones that are studied from the fossil sites, from archaeological sites, and also the recent ecosystems. Some people, like the novelist Hartley said, the past is a foreign country. They do things differently there. So perhaps there is no way to use the information that we gather from the fossils and also the zooarchaeological records to the present day. But I beg to be different. And because of these trying to connect the past with the present, and then trying to find what are the meaningful message that we could get from the deep history of the Earth, and then try to fit with the modern day conservations, has given rise to a specific cross-disciplined line of research called conservation paleobiology. What it is all about, and here I would like to quote my fictional colleague, Dr. Alan Grant, because I think he sums up very nicely what conservation paleobiology is all about. Now, in this book, written by Michael Crichton in 1991, he said that Grant knew that paleontology, the study of extinct life, had in recent years taken on an unexpected relevance to the modern world. The modern world was changing fast, and urgent questions about the weather, deforestation, global warming, or the ozone layers often seem answerable, at least in part, with information from the past, information that paleontologists could provide. So that is always the desire to link up whatever scientific information that we could get from the fossils and zooarchaeological reports to the modern world, to make all this scientific research relevant to the current environmental crisis that we are facing. Now, the history of the Earth is like a layer cake. The deeper you go, the older the geological layers. And what I am doing in my research in paleontology and zooarchaeology focuses on the uppermost layers called the Pleistocene and the Holocene, or in combinations called the Quaternarians. That is the last 2.5 million years history of Earth. And because of these time periods, whatever scientific information that we found in the fossils and zooarchaeological report from the Quaternarians can actually have direct connections with the modern world. So, by the way, as a sideline, does anyone in the audience is a fan of Sherlock Holmes or novels of Sir Arthur Conan? All right? Okay, good. We have more things in common now. Okay, one of the key principles that Sherlock Holmes or any capable detectives working on is that the amount of useful or meaningful information that one could obtain from a crime site is disproportionate to the crime when it was committed, which means that you will have a better chance to catch the culprits if the crime happened just yesterday as compared to that happened 10 years ago. And this applies in my case for the fossils and zooarchaeological research as well, because I'm focused on the last 2.5 million years history of Earth and life on Earth. And then this is basically what we are living nowadays is a logical and natural extensions of the history from 2.5 million years ago. So definitely by studying these bones, the hippo bones, the only hippo bones in Malaysia is now in public displays in Museum Negara, and also studying the Jawa rhinoceros remains from the archaeological site in Guacha in Ulu Kelantan. Definitely, when these are properly studied, we could find the information that will be useful in fitting into the modern day conservations. And one of the revelations that we got from studying the fossils and also the zooarchaeological remains is we draw the geographical range of some of the species. Biogeography is a scientific studies of the distributions of animals across the globe. And I would like to start these aspects with the distributions of modern Asian elephants in Peninsular Malaysia. Now, this is a map of Peninsular Malaysia, and the shaded blue areas represent the modern distributions of Asian elephants. And from the face of it, it seems like the Asian elephants would love to stay in the central and eastern part of Peninsular Malaysia. They try to avoid the western parts. But when we plotted in informations of the fossil Asian elephants, we think that we in a way enrich our knowledge about the past distributions of elephants. These are the fossilized cheek teeth, molars of Asian elephants found in Peninsular Malaysia. And in the much more enriched distributions of modern elephants and also the fossil elephants, you can see that there also occurs in the prehistoric times in parts of the Peninsular Malaysia where there is no longer Asian elephants around. For example, in Perlis, there was the fossils of Asian elephants found in Perlis, but nowadays Perlis doesn't have any living Asian elephants. And you can see one of the hotspots is in the middle of the state of Perak in the Kinta Valley. This is not very surprising because most of these elephant fossils found during the British colonial periods, they came from the Kinta Valley when tin mining is still actively the main economic source of the state at that time. But recently, there is a group of very active and responsible cavers based in Kinta Valley, called themselves Kinta Valley Watch, and they explore many of the caves around Ipoh, and in the process, they also found quite a lot of elephant fossils. And that explains why over here you can see the distribution map. The hotspot is always in the middle part of Perak. It's because of the scientific investigation activities of all these citizen scientists. And another remarkable examples of biogeographic range revelations from the study of fossils and also the archaeological remains is tigers and orangutans at the national levels. There is no more suitable animals than these two to symbolize Malaysia. There's only living elephants in Peninsular Malaysia. For some of you, you may not know that in Sabah and Sarawak in East Malaysia, there is no longer Malayan tigers. And orangutans, where in Malaysia that we could find orangutans? Only in Sabah and Sarawak. But when we study the fossils and zooarchaeological remains from both West and East Malaysia, sure enough, we have the tiger fossils in Peninsular Malaysia. And this is one of the sites with remarkable tiger fossils. I would like to point out that this fossil site was found way back in 1992 by the Caving Group of Malaysian Nature Society. So Malaysian Nature Society is not just the oldest environmental NGO in Malaysia, but it has contributed hugely to the scientific research, especially in the fossil research of Malaysia. This is tiger fossils from Nagamas in Perak. It is relatively complete, and you may not know which part of the skeleton may be represented. It is rather difficult to imagine. So I draw up a schematic drawing so you could see clearly as compared to the real pictures on your right. Over here, we have the back of the skull. And over here, the lower jaw, some of the teeth still attached. And further down, you have the scapulars, the shoulder blades bones, the upper arm bones, you have part of the vertebrae, you have the lower limb bones, lower vertebrate columns, and the lower legs, and then the pelvic gill that is on the upper northeast. So it is not only remarkable, but also so far the most complete tiger fossils ever found in the whole world. So this is, I take pride to be a Malaysian, because in Malaysia we not only have the tiger national coat of arms, there are still living the tigers in some of the forests in Malaysia, but also we have the most complete tiger fossils in the whole world. Towards East Malaysia, with these first evidence of tigers from Sarawak. It was reported way back in 1963 when Malaysia started to exist as an independent nation, but the fossils found was found a long time ago on 15th of February 1958. It is one of the zooarchaeological remains from Nair Cave in Sarawak. Zooarchaeological remains means that this used to be part of the food of prehistoric humans roaming the Nair Cave in Sarawak. One of the reasons I love to work on Nair Cave materials is the detail of information preserved since the early excavation in the 1950s. This is the original labels, and from it you can see very clearly all the key scientific information you need to know. It's from Nair. It's excavated from the excavation trench or areas labeled as EG1, unearthed from layer about 6 to 12 inches below the surface level. And when it was found in 1958, the original investigator thought that this might be a canine, the canine tooth of big carnivores, but they're not sure what it may be. So you have the question mark there. And it was found together with another jaw of a palander mouse ears. It is only in 1963 that when the specimens sent to the Netherlands for experts to identify that we realized that this is not the canine of the bear, but this is the canine of tiger. And this represented the first evidence of the existence of prehistoric tigers in Borneo. And we have also finding of tigers, not just in Sarawak, but also in Sabah, in a cave site called Malaya Cave, and it is dated about 9,000 years ago. This is part of the foot bone of the tigers. So now we have evidence of prehistoric tigers, not just from Sarawak, but also from Sabah in East Malaysia. From this map, the first thing you will see is that the red is the current distributions, the estimated current distributions of tigers. This is still roaming in certain areas in urban Malaysia, but unfortunately in highly endangered status. But across the pond in East Malaysia, there's no more living tigers, but there are fossils or zooarchaeological remains of tigers in not just Sarawak, but also in Sabah. And similar to the local language in Peninsular Malaysia, where you have lots of specific terms used for the tigers, for example, Ninja, Rimba, Hanbabala, Atan, and so on and so forth. But in Borneo, they also have a plethora of technical names used for the tigers. For example, the Lubawang peoples in northeast Sarawak and also southwest Sarawak, they call it Barang. The Bidayu in Sarawak call it Limong. The Kenya call it Lejao. Kayan call it Lejo. And Iban call it simply Rimang. So these rich local vocabularies used specifically for the tigers point out that perhaps the Malayan tigers was still existed in East Malaysia relatively recent in times during the historical periods. So by studying the fossils and also the zooarchaeological records, we draw the biogeographic distributions of Malayan tigers. It's not just only in Peninsular Malaysia that we have the fossils. Across the pond in East Malaysia, we also have the prehistoric records of tigers. And I would like to bring your attention to the fact that I didn't make this discovery myself. I rely heavily on the works of my academic predecessors. For example, Tom and Barbara Harrisons, who were the original excavators of the Nair caves in Sarawak, with the help of the, at that time called Lord Medway, the fifth Earl of Cranbrook now, and the Dutch paleontologists that I mentioned before that helped to identify the tiger remains the alcohol used. And also, I rely heavily on the recent work by my colleagues from Australia, Peter Bellwood from the State Terry Harrisons, and also Phil Piper and Ryan Rabbit. All these people make huge contributions towards our understanding of the prehistoric animal world in Nia and Borneo. And now come to one of my favorite animals, orangutans. The orangutans are nowadays found within Malaysia, Sabah and Sarawak only. And fair enough, we have orangutans remains from Nia, Sarawak. And not just Nia, but across some other places in the island Borneo. We have also the orangutan remains from Nia caves, Suri caves, Baolam areas, Taguma cave in Sarawak, and also Malaya area in Sabah, and also as far down south as Kalimantan. All these areas produce some of the magnificent orangutan remains. But again, across the pond, in the opposite side in East Malaysia, in recent years, my colleagues and I could explore some of the large areas in Peninsular Malaysia, for example, this cave in Pahang, and we found lots of evidence of prehistoric orangutans in Peninsular Malaysia. These are all the fossilized teeth of orangutans. And strangely enough, there are a number of them that shows pathological signs. Caries, dental decay. So these also show us that in prehistoric times, orangutans also roam across Peninsular Malaysia. They are not just limited to Sabah and Sarawak as well. And in Peninsular Malaysia, we have found orangutan remains from at least 4 different geographic areas. Up in the north in Lengongs, and then down south in the Batu Caves areas, into the central part of Peninsular Malaysia's Melapo, and then again in the central part of Perak in Kita Valley. We have a lot of orangutan fossils found. Some of the sites have been dated. Some of them are as old as about 500,000 years ago, and some that are newly discovered that we haven't really yet dated them. So we have no ideas how old in geological terms these orangutans in Peninsular Malaysia may be. So if you are interested to know more about the orangutan fossils in Peninsular Malaysia and want to read more about the technical report, here are some of the 3 papers that you want to download it from the internet and try to read them. All this contains quite a lot of useful information. So through the hard work of generations of paleontologists, we now can really map up the prehistoric distributions of orangutans. Nowadays, orangutans are limited on the island of Sumatra and also Borneo, but the fossils and zooarchaeological records shows that in prehistoric time, orangutans, the ancient great apes had a huge geographic distribution, started from the southern side of China down to the island of Java. So this is one of the major revelations that we got from the study of fossils and zooarchaeological records. Because if we limit our knowledge on the current time frame, we'd have a much poorer understanding of the prehistoric distributions of these ancient great apes. As I said, the modern day orangutans distributed only in parts of Southeast Asia, Sumatra, and Borneo, but in the prehistoric times, when all these islands were connected into a subcontinental area called the Sundaland, they have quite a wide distribution. And one of the common themes of the tigers and also the orangutan is what we are seeing now is simply the result of a tilt of declining geographic range. The tigers used to be in West and East Malaysia, but now limited only on West Malaysia. The orangutans are limited on East Malaysia nowadays, but during prehistoric time they have a huge distribution range. So what we are seeing about the orangutans and the tigers nowadays are merely the related populations of the once widespread prehistoric populations in the past. Another aspect that I learned by studying the fossil and zooarchaeological records of these mammals is about the reduced diversities that we have today. So we live in a much poorer world today as compared to the prehistoric time. This is the only native bear species that we have in Malaysia, whether it's West Malaysia or East Malaysia, so Malaya's sun bear. But in the regions nowadays, there's another species of black bear called Asiatic black bears. But to your right, you can see that the distributions are mainly in the northern part of continental Asia. They never really ventured down into the southern Thailand or Peninsula Malaysia. But that is not always the case when we look at the prehistoric records. These are the fossilized teeth of bears found in a number of states in Peninsula Malaysia, from Selangor, Perak, and Pahang. And then by studying the detailed morphologies, we know that this is not the Malayan sunbear. Definitely not the Malayan sunbear. This is a much larger bear than the Malayan sunbear. This is the Asiatic black bear, which represents the first record of Asiatic black bears in Malaysia. And what is most interesting is that in some of our sites, we found not only remains of the Asiatic black bear, but also the Malayan sun bear as well. So, in a sense, it shows that during prehistoric times, the bear as a group of mammals enjoy a higher diversity than at present, when there is only one species living today. And the finding of Asiatic black bear fossils in Malaysia also explain another riddle of biogeographic in Southeast Asia. As you can see, the yellow parts represent the living distributions of Asiatic black bears, but our colleagues in Indonesia also found the Asiatic black bear fossils in Java. But there is no records of living or fossils Asiatic black bears in the areas in between, until they found some fossils in Peninsula Malaysia. So the finding of fossils have implications, perhaps indicating that Peninsula Malaysia used to be an important migration route for ancient mammals from continental Asia down to island Southeast Asia. And we are so lucky that we not only found the Asiatic black bear fossils, but we also published some results in local journals. So if you are interested, you could try to download the PDFs from internet and read from them all the very rich information. All right. I'm going to talk about pangolins, and then this is a very unique and very primitive mammals because it is the only mammal species in Southeast Asia without any teeth. So, and there is only one species of pangolins in East and West Malaysia, which is the Sunda pangolin. But again, like the Asian black bears, this is not always the case in prehistoric times. In Borneo, in Nia, at a very old geological layers that dated to be around 45,000 years ago, we found a giant species of pangolins. It is estimated to be around 3 meters in length, about 2.5 times larger than the largest modern day Sunda pangolins. Over here, this is a toe bone of a living Sunda pangolin, and this is toe bone of the giant pangolin. You could easily see the difference in size. And again, I would like to stress that Nya is very beautiful because of these background information preserved since the early excavations. So if someone like me is interested to study the Nya materials, we make a lot of use of these old information contained in the museum's archives. And within Southeast Asia, Java is the other areas where remains of giant pangolins has been found. But in a much older geological layers dated around 770 to 126,000 years ago. So giant pangolins existed only in these two parts of Southeast Asia during the prehistoric time. And again, I would like to stress that this is not my findings, and I would like to record here my thanks to some of these my academic predecessors who have made huge contributions towards our understanding of the prehistoric world in Borneo. I'm coming back to this map again, which shows the current distribution of Asian elephants, but also I also plotted out one of the ancient elephant species that we found recently, just only recently, during the COVID periods from the Kinta Valley, the stegodons. So how does a stegodon look like? You can see over there, there's a stem from India, and then it is so primitive looking. So actually, it's the ancient relatives of elephants. And today I also bring a model of the stegodons. The stegodon, the adult male of stegodon, which is different from the Asian elephant, is their tusk. They have long, huge, and slightly upward turning tusks that grows so narrowed in between that there's no enough space for them to rest their trunks. So they have to rest in the trunks on either sides of the tusk. So this is one of the characteristics differentiating Asian elephants and also these ancient elephant relatives called the stegodons. Stegodon fossils have been found in many areas in Southeast Asia. In Thailand, we have lots of stegodon fossils. In Indonesia, especially the island of Java, we have lots of stegodon specimens. But strangely, Malaysia has only one recently found fossils in Kinta Valley. So it points out that during the prehistoric times, we not only have the fossil representative of living Asian elephants, but we also have another species of the elephants relatives, stegodons. And now move on to another. This is not Asian elephants, but plotted against the distribution of Asian elephants and also the fossils of Asian elephants are what we call the Asian straight-tusked elephant, or known scientifically known as Paleontological. This is a much larger elephant. And how does it look like? Over here. This is the reconstructed models. It bears a relatively straight tusk in the adult males, and what is so special is the head of the individuals. You see the bumps as compared to the stegodons. You can clearly see the head of there's a distinctive bumps on the Asian straight-tusked elephants, but it's relatively flat in the stegodons. And now compare it with our living Asian elephants. you could see the differences in the morphologies, not only of the tusks, but especially the skulls. So by studying the fossil remains from paleontological sites and also the zooarchaeological records, we realized that during the prehistoric times, there's not only the fossil representative of ancient elephants, we have two more species of ancient elephants, the Asian straight-tusked elephant and also the stegodons, a much higher diversities in the past as compared to the present. And now moves to a group of ancient or very, very primitive looking angulates. Okay, the tapirs and the rhinos, they're all grouped together called the parasaurdactyl, or the odd-toothed angulates. And that occurs not very lately in East and West Malaysia as well. But nowadays, with a much reduced diversity in East and West Malaysia, there are still living tapirs in West Malaysia, and then the Java rhinos and small rhinos were recently extinct in Peninsular Malaysia, but sadly in Borneo, the whole of Borneo, there's no more living parasaurdactyls or odd-toothed angulates anymore, because we have no living tapirs in Borneo, not in Sabah and Sarawak or Kalimantan, and then we have no more rhinos in Sabah or Sarawak with the recent death of the last wild Sumatra rhinos in Sabah called Imam. So that's why I'm saying that we are living in a much plural world today as compared to the prehistoric world. Now, these are some of the fossils of the rhinos found in Peninsular Malaysia. And very strangely, even though that tapirs today dominates the landscape in West Malaysia, whereas some of the rhinos were already declared extinct in West Malaysia, but in fossil sites we found more rhino fossils than tapirs, which is a very strange thing. And during the MCO lockdown periods, I also have some time to plot out the prehistoric distributions of the two species rhino in Peninsular Malaysia, and you can see that occurs quite profusely in certain parts of Peninsular Malaysia, where nowadays there's no more living rhinos. Anyway, in the Peninsular Malaysia. And in Sarawak, again from here, we have the subfossils remains of the tapirs. These materials were actually found in 1961 and also represented the first evidence of the existence of tapir in prehistoric Borneo. Some people say that extinction means forever. There's no way that we could bring back the stegodons or the Asian straight-tusked elephants into Peninsular Malaysia. But in some cases, perhaps we will make some exceptions, like the tapirs in Borneo. I just mentioned that there were zooarchaeological remains of tapirs in Sarawak and perhaps also in Sabah. These were the ancient hunted animals from Sabah and Sarawak. And also unconfirmed sightings of tapirs have been reported in Brunei, in the Gulf Coast, way back in the 1980s. And some of the geologists doing surveys in the Ulus Gama areas in Sabah noticed animals with black and white skins. So these are the unconfirmed sightings of tapirs in recent date Borneo and Sabah and Sarawak. Perhaps we could make an exception over here that by studying the zooarchaeological records, we provide a very positive evidence of the existence of tapirs in prehistoric Borneo. And nowadays, Borneo in Sabah and Sarawak still has quite large areas of forested areas. Perhaps someone could really propose the reintroductions of some of the Malayan tapirs from Malaysia to some parts of Sabah and Sarawak. And I will talk about these big species in Peninsular Malaysia. This is not the usual wild boar species that you see in Malaysia. It's called the bearded pigs. As compared to the common wild boar species, I think that this pig is more charismatic, it's more handsome. And from a biological point of view, bearded pigs represent a group of wild boars that are truly Southeast Asian. They originated, they evolved in Southeast Asia, whereas the common wild boar that we see today is running in the jungle areas. These are the invasions from Eurasian continents. So nowadays in Peninsular Malaysia, we still have a limited populations of bearded pigs over here. You can see this is the skull of the common Eurasian wild boar, as compared to the much larger bearded pigs. By studying the pig remains from paleontological and zooarchaeological sites in Peninsular Malaysia, we found that during prehistoric times, the bearded pigs has much wider distributions at the Peninsular Malaysia, as compared to the modern day distributions in very limited areas between Selangor and Perak, and also in Southeast Pahang and the adjacent environment areas of Johor, or in the forest areas of Peninsular Malaysia. But how long this situation can remain? Would the pig species in Peninsular Malaysia follow the fate of other mammals like the rhinos and also the bears, where further down the road we have only one species of wild boars living in Peninsular Malaysia? This remains an open question. Now, apart from the reduced diversities in terms of species, perhaps we have also detected a reduced diversities of morphology and genetics in modern days mammal fauna as well. Now, I study the prehistoric orangutans, and I focus on the teeth. So I studied the morphologies of the fossil orangutan teeth, measured them, and when I plotted the size variations of the teeth of modern orangutans, this is the range of variations of modern day orangutans, and this is the variations of the size of the dentitions of prehistoric orangutans. And you could try to compare. That is a substantial decrease in the degree of morphologies of the modern day orangutans as compared to the fossils. What we are seeing today is just only a minor part of what used to be a more diverse orangutan populations. So in the conservation world, there is these constant fightings of the conservation. It is against alien or introduced species that are harmful to the local ecosystems. Very well-known examples would be the rabbits in Australia, and also the feral domestic cat in some of the islands in the Pacific, like the Hawaii's. They do more harm to the native bird fauna and the local ecological systems. And so many of the conservationists are trying to get rid of these alien or introduced species in order to protect the truly endemic native ecosystems. But in the real world, sometimes it's not very easy to distinguish whether a species is introduced or native. There's no clear-cut example as the Australian rabbit and also the feral wild cats, domestic cats in Hawaii. And that is where fossils and zooarchaeological research comes into play. And I would like to start with the Asian elephants on the island of Borneo. Now, the Asian elephants in Borneo has a limited distributions in certain parts of eastern Sabah and also the adjacent areas of North Kalimantan. And the numbers is not huge. So that is these notions that why the Asian elephants of Borneo has such a limited geographic distributions and also low numbers is because some historians believed that these elephants were the feral descendants of introduced animals during the 16th century from the Sulu Sultanate. Sulu Sultanates have the seat over here, Sulu and Olympus. And some of the historians believe that in the past, some of the elephants were gifted to the Sultan of Sulu as a diplomatic gift. And because Sulu has such a small area, the Sultan decided to dump the elephants in much bigger areas within his territory, which is Northern Borneo. And that may explain why the current distributions of the elephants is only limited to Sabah, and they have small numbers. But genetic studies give another story. Through the genetic studies of living elephants in Borneo, we found that they have a much ancient ancestry than what the historians or the Philippines scenario indicate. If the scenario proposed by the historians that these elephants introduced into Sabah during the 16th centuries, normally, usually, the elephants, living elephants devoted to this would have a low genetic diversity. But genetic studies in recent years found that this is a different one. It has a high degrees of genetic diversity. And the genetic diversity pointed out to a very ancient ancestry for the living elephants now living in Sabah. So some biologists counter argument that is it because they are from the island of Java. Island of Java used to have a distinct subspecies of Asian elephants, but now extinct already. And perhaps during the historical periods, the elephants that were gifted to the Sultan of Zulus came from these subspecies of Asian elephants from the island of Java. And that may explain the ancient genetic diversities of the living elephants nowadays in Sabah. And one of the key arguments that the historians and the scientists always have is if the Asian elephant is truly native to the Borneo, why there is no evidence from the fossils and zooarchaeological sites. Whereas in Nia, since the excavation in the 1950s, they have produced lots of animal remains. Some represented animals no longer present in Borneo today, like the tigers, the Jawa rhinos, the giant pangolins, and why there is no Asian elephants. The Asian elephants are truly native in Borneo. But here's the evidence. Here is the evidence that generations of scientists and conservationists are looking. And what is most interesting and fascinating is that these specimens were found in 1958, before Malaysia was born. But unfortunately, it went unrecorded and unnoticed for about 6 long decades until I restart the studies in Sarawak Museum, trying to look for some interesting materials for research in the exploration units, and I accidentally made a rediscovery of these important specimens, which proved critically important to the current debates of whether the Asian elephants living in Borneo today is truly native or introduced alien species. And very interestingly, in recent years, the archaeological layers which produced these specimens were dated by teams from Cambridge University, and it indicated that these specimens was at least 10,500 years old. So this is the first proof that Asian elephants was once a native mammal in Borneo, at least since 10,500 years ago. And I would like again to record my thanks to my academic predecessors, Tom and Barbara Hansen, who investigated Nia in the early 1950s, and Lord Cronenberg was on the scene since the 1950s. And then when I told him about the rediscovery, he really encouraged me to do more research and then encouraged me to publish in the Malayan Nature journals about the rediscovery. So I would like to record my profound thanks to these three giants of Borneo prehistory studies. If not for their visions, diligence, and also their pioneering works in Nia, our knowledge about prehistory Borneo would be much poorer. And as a sideline, all these three have connections with the society in one way or another. Lord Cranbrook is still alive, approaching his 90 this year. He is an honorary member of MNS and is one of the editors of the Malayan Nature Journal, the in-house journals of Malayan Nature Society. And Tom and Barbara Hansen were instrumental in bringing the society across the pond to set up in Sarawak some of the branches. Right, this would be one of my last sections of presentations. I want to go back again to the Borneos and talk about the orangutans. Right, these are some of the examples of the orangutan remains in Nia caves. It's only tip of the iceberg. Nia caves have produced so far the large amount of orangutan remains in the whole world. And then, when I look at the modern distribution of orangutans in Borneo, we can see that they are living in scattered pockets of forest in the north, and the east, southwest. But strangely, there is no wild living orangutans anywhere near Nia. Within the 200 kilometers radius of Nia, there is no more living orangutans. Whereas in the prehistoric time, there's lots of orangutans. Why is this so? And this brings to the last section of my talk, prehistory hunting. Prehistory hunting is smoking gun over here. There are many orangutan remains from Nia, so I started to look at the dentitions. Orangutans, like modern day humans, they have two sets of dentitions. The male dentitions, also the permanent dentitions. So by studying the dentitions and also the eruptions of the dentitions, one could actually know roughly the biological age of the individual at death. So for example, these orangutan remains is from the upper jaws and individuals is from Gangira on the sites in Nia caves. And over here you can see that there are the two teeth. And back over here, hidden away, is the permanent teeth that's not yet erupted. So when we compare to the modern chart of the eruptions of babies, orangutans, dentitions, and also the adults, we know that these individuals, when it meets its end, is roughly less than 4 years. By just looking at dentitions, we may know the biological age of these individuals. And so I go through each one of the 200 plus specimens from Nia and try to figure out what their biological age could be, and I plotted out against the archaeological levels. There are three main sites in Nia caves which produced orangutan remains. One is Gangira, Lobangus, and Westmouth. And regardless of whether you're looking at the young archaeological levels or old archaeological levels, the studies of the dentitions indicates that most of the animals hunted during prehistoric time, they were from the young and juvenile individuals. And sometimes it's even possible to determine the sex, the gender of the orangutans by looking at the bones and the dentitions. And when it's possible to do so, I also plotted out the proportions of these genders from all three sites in Nia caves, and we also found that there's a predominance of female. So I started out by asking these questions. what insights these reconstructed mortality profiles can tell us about the past hunting strategies, and there's a dietary references of the prehistoric hunters in Yang. And regardless of which sites they are living in, and regardless of whether they are from a very old prehistoric hunting populations or a recent hunting populations, they always targeted at young animals and females. And this makes sense because it is very dangerous, not easy to hunt down the adult dominant males. And what implications these information from study of the bones and conditions of orangutans can tell us about modern day conservation. Huntings need to be strictly controlled. Some of the animals, like the orangutans, they are slow breeders. They're an adult fertile females usually produce young babies for every 6 or 8 years. So they are naturally slow breeders. And slow breeders, they are highly vulnerable to any decrease of huntings, even though it is a very, very limited hunting pressure. So in order for us to save the orangutans from extinctions, poaching, illegal hunting need to be controlled, monitored, or even prohibited totally. So this is the concluding slides of my talk. No more pictures of the prehistoric humans, no more pictures of bones or teeth, but only words. But these words, I think, is to bring home that message to every one of you over here. So, the Malaysians that we are living nowadays, specifically and generally in Southeast Asia, they have a highly diverse mammal fauna because of the unique geographic locations in the equator. And also in combination, they have a long and dynamic evolutionary histories between the fauna and the environment. So what we learned from the past, from the archaeological and fossil records, is that many of the species, they have a vast and almost pan-Sumatra distribution in the past. And nowadays, they only live in fragmented habitats with the young and pocket distributions. So what modern day conservation could help? Perhaps reintroductions or rewilding, reinstate their former distributions. For example, the reintroductions of tapir into Borneo. And in terms of diversities, in the past we have the highest species diversities within a single geographic areas in Malaysia, for example, we have in the past 2 species of black bags instead of the only 1 species we nowadays have. Perhaps this may imply that a high degree of coexistence in space and time. Perhaps there is a greater habitat heterogeneity in the past as compared to today. And also at another level, there was higher morphological diversities in the past, like orangutans, which have a huge morphological variations in the past compared to today. So perhaps there is a greater genetic diversities and higher chances of genetic exchange in the past as compared to the present. What we are seeing today is just low survivors with low diversities. We have only 1 pangolin species in Peninsular Malaysia and also in West Malaysia. There's no more giant pangolins over here. And what modern day conservation scientists should do is to perhaps increase the habitat diversity. Even if it means cutting down some of the trees to create pastures for some of the grazing animals today, for example, the wildcatters of Sladang or buntings. These have actually been carried out years ago somewhere in Kuala Tahan, and perhaps these could be encouraged more in modern day protected areas, for example, in Taman Negara or Royal Balloon State Park, that some areas can actually be created to maintain higher diversities of grazing animals in the protected areas. And also, in order to maintain a higher genetic diversity, perhaps the habitat should be connected once again if they are fragmented today. And this would increase the genetic connectivities of isolated populations of mammals. And by studying the fossils and zooarchaeological remains, we also clarify the evolutionary histories of certain species, whether they are introduced or indigenous species, and this help in turn that the conservation should really prioritize their targets of truly native species and not the introduced species. A large response to hunting. Different species respond to hunting differently. Some species like orangutans, like say, they are slow breeders. They are highly vulnerable to any degrees of hunting. But some other species, like the wild boars, they are fast breeders, and there are many little in one size. So different species that reacted differently towards hunting pressures, and that points out the importance of studying the natural history, ecological requirements of species. So that explains why in the beginning of these presentations, I used the quote from Lim Tze Tshen. And I would also like to quote him at the end of my presentations. The further backward you can look, further forward you can see. So that is a strong conservation message that we can learn by studying the fossils and the zooarchaeological remains in Malaysia. And hopefully these information can feed into modern day conservation science and also beneficial to the conservation world at large. So, these, thank you very much. They are not the same scales. The modern Asian elephants are usually smaller in size than the stegodons. But there are also some species of stegodons that live on islands, and it is a well-known fact that island animals tend to be smaller in size. So there are some stegodon species in the islands of Indonesia, for example. They are much smaller in size than the Asian elephants.
Second question is, oh.
The Bornean elephants now looking at the evidence, we tend to think that it's a native species instead of introduced. Be it from the genetic evidence, also the evidence from zooarchaeological records, all pointed out that at some point in the past, Borneo has the Asian elephants. So it is highly likely that the living Bornean elephants nowadays in Sabah and North Kalimantan, they are descendants of a truly native indigenous species.
So when you say Asian elephants, actually the Borneo pygmy elephants?
Yes, they are not pygmy at all. They are not pygmy at all. They are almost similar size to the living Asian elephants.
Lim, you made references to studying some of these fossils from near caves. Can I ask, where are these specimens kept and under whose jurisdiction?
The legal owner of all these materials are the Surrounding Museum Department, and the zooarchaeological specimens, non-human animal bones, have a long and winding histories. They was excavated in the 1950s, started by Tom and Barbara Harrisons, and because at that time there's no local expert to study the materials, so they sent the bulk of the materials to Europe, to Netherlands, in order to study by Dick Albert Hoyert. And when the study finished and Dick Albert Hoyert retired from the museums and passed away, all the materials remained in Leiden.
In London?
Leiden, Netherlands,
Oh, Netherlands.
at that time. But in recent years, throughout museums request back all these materials, and Leiden happily returned all the materials, and they are now safely in the new Borneo Cultures Museum in Gucci.
And are these exhibited for public to see?
Unfortunately, the exhibited materials compose only about less than 1% of the all the excavated materials. Yeah. And many of the materials they are still kept in the storage and then for research purposes. Make a trip, huh? MNS trip. Please, listen.
So the primary cause of extinction of the Borneo tiger and the peninsula Malaysia orangutan is poaching?
We are not entirely sure about the cause of the extinctions of the tigers in Borneo and also the orangutans in Peninsula Malaysia. But poaching may be one of the reasons. We have to look for other reasons as well. For example, environmental changes, climate changes, and also perhaps the tigers in Borneo have already have a low genetic diversity, so a little amount of hunting pressures could easily wipe out all the remaining tigers in Borneo. It's perhaps similar to the orangutan in Malaysia. This is something that we still need to have more investigations on. What we are now clear is we are scratching the surface. We pointed out that in prehistoric times there were tigers in Borneo and there were orangutans in Malaysia. But that's not the end of the story of our research. We still need to continue on and hopefully we could really pinpoint out what is the combination of factors that cause the extinctions of these animals from some of the islands.
You were talking about reintroducing or rewilding, and one species you talk about is the tapir. What about trying to reintroduce tigers to Borneo?
Oh, that would be highly controversial. I'm feeling the heat now. So, introducing seemingly harmless creatures like the Malay tapirs into certain areas, the forest area in Sabah and Sarawak, would not cause much harm to the local communities living in the areas. But introducing a top predators, you might need to have a second thought because you need to ensure that the tigers that you release in, for example, in somewhere in Kuching areas, in Kuba National Park, they will have enough wild boars or enough somebody over there for the tigers to prey on. Or else they will just go to the Kuching areas, go to the museum, and then see you in the Borneo Culture Museum. So you need to make sure that whatever animal species that you want to introduce into the areas, you have the solid scientific basis, and then you carry out the ecological or habitat suitability research and adhere to the strict rules and regulations set up by IUCN. It's not always possible, but sometimes it's possible. Like for example, orangutans. When you have the suitable parts of the skeletons, for example, you have the pelvic bones, or you have the dentitions. Perhaps you could tell that okay, a female would be more gracile, and it would be more smaller in the sides, and then the male would have a bigger dentitions. Then you could try to determine the gender of the fossil animal. Oh yes, of course, yeah, yeah.
So I think the very recent one that you did, which is you said that was done during COVID, which you found, and then it has to be sent out of the country for them to. Do they do carbon dating to tell you how old some of these fossils are?
Which you mean the sterodon?
Yes.
The sterodon fossils was found by citizen scientists from Kedah Valley Watch. They notified me about the findings, and then I confirmed that it is a sterodon that first in the whole country. And it was found during the COVID period, and then my colleagues from the University of Malaya, Dr. Lewis is at the back of the audience. She and I went there to check on the fossils, and we, both of us, were among the first scientists in the whole country to go to the field and look at the specimens in situ inside the cave. And these were later on extracted out because we wanted to do a more detailed studies of the specimens. And then samples of the rocks surrounding the fossils were sent outside to try to determine the geological age of the fossils, but the specimens retained in Malaysia since its first discovery even now. Actually, the specimen is not far away from Rimba Ilmu in the geology departments of UM. Yeah.
Yep. It's true.
So which means you have the means of determining the age of the fossil in Malaysia itself without having to send-
Not in Malaysia. We do not have a reliable equipment over here in Malaysia, and so we have to rely on our colleagues overseas. And apart from carbon datings, there are lots of dating methods nowadays. They want to try to get a more refined dates, geological dates of all these fossils.
So I noticed that most of your discoveries are in caves. Is there any special reason why these specimens are always found in caves?
Caves provide protected conditions for some of the animal remains. The soils outside the caves in tropical areas like Malaysia, they are usually acidic and they are corrosive to the bones. And so, but the soils inside the caves is slightly more alkaline, and this provides better preservation conditions for the animal bones of teeth. So there is a higher likelihood that we could find fossils of animals inside the cave rather than outside the cave in the tropics. But having said that, that doesn't mean that outside of the cave doesn't contain any fossils. Many of the old Asian elephant fossils found in Malaysia, they are from the old tin mines outside the cave. And one of the most productive fossil sites in Southeast Asia is the island of Java, and almost over 95% of the fossils are from the open air site outside the cave. So, but for us in Malaysia, based on my experience, it's relatively easy to find fossils inside the cave rather than outside the cave.
Mr. Lim, I would like to ask something about diversity. So, since your discovery, I noticed mostly, like you said, is in limestone caves, which means it's the tip of the iceberg in terms of megafauna diversity. We're trying to judge the Pleistocene megafauna diversity. So, since Sundaland would be most likely characteristic of the Pleistocene habitat, like in the mammoth steppe, the Africa savanna, like nowadays, and in terms of our track record, we had more diverse megafauna nowadays with the Seladang, the grouse, the bantangs, and everything. So, since we can't recover the fossils down in the Straits of Malacca or South China Sea, do you think that there might be more megafaunas that is not just restricted to the limestone caves, or would it be more homogeneous as in your discovery?
Oh yes, of course. Our samplings are limited to limestone caves, like you rightly mentioned. And so when we tried to plot out the geographic distributions of these fossil animals, it tends to follow the distribution of limestone cave. And where in areas where there is no limestone cave, and usually there will be a blank our distributions. And that is something that will be out of our control. But hopefully, we may improve our sampling efforts outside of caves and try to look for potential fossil sites in the open areas so that we could see what might be the difference in terms of diversities of animals that we found inside the caves and also outside the caves. And of course, South China Sea and also Strait of Malacca are highly potential areas for looking for fossils, but it would require some specialized equipment like deep sea trenching. But there is already an example in the Taiwan Straits where they have recovered lots of fossils of elephants and water buffaloes in the Taiwan Straits. So perhaps in the future we can really try to look for fossils in some parts of the South China Seas and also in the Strait of Malacca. But that would require a teamwork, a highly skilled research team. At the moment, unfortunately, Malaysia doesn't have one.
Another thing, is there an estimate in terms for the Indo-Chinese migration to Sundaland, like the Asiatic black bear and the other neophones?
We think that during the Pleistocene, when all these lands were connected to one another, the animals can actually freely roam across the areas which are now separated by oceans or straits. But during the Pleistocene period, there would be lots of chances for animals to migrate between continental Asia and also to the southern part of Southeast Asia. I think that the chances would be in the middle part of the Pleistocene period or towards the end of the Pleistocene period, during the Ice Age periods when the sea level is much lower than at the moment. So there would be more than one migration route, more than one migration wave of mammals from continental Asia to Southeast Asia.
In terms of geological time scale, the submersion of most of the Sundaland is quite decent, would be quite short. So, do you think in both geological and biological time scale, it would be enough time for the animals to submit to insular dwarfism and insular gigantism? Because we've seen some of the animals are quite small, but some are quite constant, like the Sunda clouded duck.
Yeah, in order for the animals to become smaller in size in island conditions, the islands need to exist for a sufficiently long time. So, for example, Borneo is a large island as compared to some of the smaller islands in Indonesia. So it is so large that it attained subcontinental in extent. So some of the animals in Borneo, for example, the native Borneo elephants, they are not much smaller in size, even though they are commonly known as the pygmy elephants. But in some of the smaller islands in Indonesia, even nowadays, we could see a larger forms of animals like the Komodo dragons. And during prehistoric times, there are lots of pygmy stegodon elephants, a small size like Alsatians. Nowadays, living in some of the islands in Eastern Indonesian islands like Timor or Flores Islands. So in order for the animals to really change their body sizes as an adaptive response to local environments, the areas need to have a sufficient time to either become an island or connected to the continent.
Thank you very much.
Any more questions? I think we Malaysians are very stingy in giving applause. Can we give a big round of applause? Great job. Very dedicated and very knowledgeable young men. Yeah? It's such a privilege that we have you here today to actually tell us all the unique details that we'll never get anywhere else. Do you know that Malaysia have 3 species of elephants? But do you know that Peninsular Malaysia actually has orangutans? I mean, these are very good knowledge, right? And I think maybe we could have it back another time, maybe, not that soon, but maybe another time. And maybe we'll do a better promotion next time. Like get all the young ones to be excited about, paleontology. And we have, maybe another extra speakers, because this is a gold mine. We haven't even touched just the iceberg of this, rich data and rich knowledge of Malaysian paleontology. Okay? I think we have a small gift for us. I would like to invite Bernie to give a small token from MNS. Thank you very much.
All right, thank you. Oh, I love it.
Thank you very much. Thank you. All right. Thank you, Asen. So we would like also to record our thanks to Rimba Ilmu, Dr. Yong, and also to MNS Photo Group for taking all the videos. So once they launch the video, I would like to encourage you to actually share with your friends. I think this is really, really wonderful knowledge that we don't want others to miss out about the rich biodiversity, the rich history, the rich fossil findings of Malaysia. Okay? With that, thank you very much for attending today's event. And if you would like to talk to us more during the coffee break or the tea, you can always do so. Okay? Thank you very much, everyone.